So I'm officially recording at this point. So today we're going to do some real kind of easy, simple stuff. We're going to do photo rendering. And I know the other section doesn't do this, the other professor, but you guys are going to have to do a bunch of this for capstone when you make pretty pictures to make your final project posters. So I thought I'd go over it and give you an introduction. So I am going to share my screen with you guys. And if we have extra time at the end of the class period, I'll start going over some of those homeworks that you had. And we'll talk about, what is the test going to look like next week? Because remember, you do have a test next week on the 18th. So it will be assembly drawings and piece part prints. So just like the homework I gave you, I'm going to give you a full assembly, all assembled, good to go. You're going to have to do the assembly drawing, and you're going to have to do 2 piece part drawings from the stuff in the assembly. Okay, so let's start a new part here. Let's do something near and dear to all of our hearts. See, I will draw a circle with a diameter of 2.600 inches. Get out of this and we'll extrude it 4.75 inches. Get rid of the planes, get rid of the axes. There. Now, I bet you can't imagine what this could ever possibly be. So we kind of went over before how to change the color of objects. So if I'd like this to be a different color, I can click on the Appearances tab. I'll choose whether I want to put the modification on the face. So, I could make this outer face maybe, I don't know, a nice Coca-Cola red, something like that. So that's pretty easy. When you want to get to the more complicated stuff, we're going to turn on the rendering tools up here. So to turn that on, we're going to come over to tabs and we'll go down to render tools. And that will give you this little tab. Okay. As you saw from my example, on my soda can, I've got the actual Coca-Cola label wrapped around it. So let's go over how to do that. And to get there, it's a little bit weird in my opinion. You got to start off with Edit Decal. So we'll start editing the decal, and we're going to browse for an image path. So out on the website for this lesson, I've got Coke 001 and Coke 001 rotated. I'm going to choose the rotated version. And I'm going to click that cylindrical face. And that actually wraps the image file right around the part. You can use bitmaps, you can use JPEGs. Solidworks also has a P2D format. So it's pretty flexible on what you can wrap around. Okay. And once you click on the surface to apply the decal, you can rotate it if you want. So I think I'll put it this way. And if you want to get really specific with it, we can come over here to the mapping tab. And this gives us a whole bunch of control over how that decal gets applied. So for example, I have the rotation down here. If I really want to get it exactly right, I could do something like 90 degrees. And it does help to use the up and down arrows. Oops, that doesn't look right. Okay, let's change it to 0. Okay, that's a little better. So I'll make that 0. And you can do all kinds of fun stuff. So you can rotate it around the cylindrical surface. We can move it up and down. Oddly enough, and you can do this stretch. The one thing you can't do, it does want to keep the aspect ratio. So if you grab this little knot point right here, it doesn't just stretch it upward in the Y direction. If you do want to do that, however, and I have to admit, that lettering looks kind of scrunched up to me. So I'm going to get rid of fixed aspect ratio. And now I can use this height slider to actually modify and stretch that lettering to look a little nicer. And then I'll center it. Okay. And this is how I got the label on my Coke can. You can see over here, I've got a little overlap going on. So we can fix that. I'll come down here to the width. And I'll unstretch that a little bit. There. Now it just overlaps. That's pretty good. So if you guys want to go put the Coke can label on your Coke cans, that's how you apply a decal. But let's say I put the wrong decal on. So I'm going to accept this. I'll say, okay, there's my decal. If you want to get rid of it, I'm going to click on Edit Decal. Whoops, excuse me. So we have the View Decals tab right here. And if we click on that, we get a list of all of the decals that we've applied. So for example, if I want to get rid of that, oops, I can just hit delete. If I want to get rid of this coloring, I can get rid of the color application by saying remove appearance. Okay, let's try a different decal, something that's fun in a kind of a different way. So we will do edit decal, we'll browse, and under downloads, whoops, sorry, I put it on my desktop. Let's try putting the Humane Engineering logo on the can. So we can rotate it around, get it about right. Click off the aspect ratio. Okay, that's pretty good. But this logo that I just put on, this has a white background, and maybe I want to get rid of that. Maybe I want it to appear as though the logo were actually stenciled over, the hood of my Ferrari or whatever's behind the logo. So we can make this white background clear. So let's see, we will come over here to view decals. I'm going to edit this decal. And we're going to use a selective color mask to get rid of the white in the back and leave just the colored portions. And this is a little bit clunky in my opinion. So you got to choose selective color mask. We're going to come down in here to selected colors, double click, choose one of the boxes for custom colors, define custom colors, and now you can choose on the white area. It's going to give you a little ding that says kind of, hey, you made an error, but just say okay. And it will get rid of the background. You do get some of these jaggies. If you had something more of a monochrome style bitmap, these would be better. Okay. But that's how you apply a decal and make the background go clear. And if this were much larger, these jaggies wouldn't appear nearly as bad as they do right now. Okay. So that's how you do a decal. Those are kind of fun. When you get to your senior project, you may have some cool machine that you're building and you can put logos all over it, make it look like a NASCAR or something like that. So again, if I want to get rid of it, you come under the beach ball for the display manager, come under view decals, and we can just delete our decal. So those are nice. Maybe you want to do something like take your cool part and do a background scene for this thing. Okay, so let's edit the appearance. Oops, I think I messed that up. Let's do edit scene. And we'll change the background image. So we'll choose this nice little plaza scene. There you go. So we can zoom in, zoom out. And we can also, we can change the shadowing, we can change the lighting. So once we get our object, let's say that looks good. Okay, but it's a little bit strange because you got the sun here and yet the shadows are down here and the light's in front. So it doesn't really make sense, but we can modify all of that. We can come under the lights and we can modify our lights. So let's say we'll show all of our lights. And here's where the light is. And we can grab this light now. Come on. Edit the directional light. And we can make it look far more like where the light source should be in this case. You can move it all around. You can add lights, subtract lights. We can bring up the ambient brightness if we want. And guys, you can get absolutely out of control with this. I've seen people spend days and days and days trying to get just that last little bit of perfection in photo rendering. You can change the color of the lighting. You can do all kinds of crazy stuff. Let's see, let's turn those lights off. So that would be how you would get the brightness in this case to match up with where the light source is, so it doesn't look weird. Yeah, let's see. So that's how you do a background. That's how you move the lighting around. We can also apply textures. Let's click on this face. We'll go back to our render tools. Let's edit the appearance of that face. So we went over how to do just solid colors. Okay, and those are fun. But let's say I want to apply like a golf ball dimpled face, or if I want to apply maybe diamond tread plate, something like that. Under surface finish, we have all of those fun kind of textures. So you can apply the texture. You can use a little box. You can scale your texture to whatever looks good to you. Okay, and all of this stuff that I'm doing, it's very, very video card dependent. I have a super high-end card in my machine, but I never ever test on this because you may find that you jump on this stuff and about half of the class can typically do these functions. So do not worry about being responsible for this stuff. So again, if I don't want to have orange diamond plate, I can simply come under the view appearances. There's my orange color. Oops. Color and the texture went together on this one. Okay. Let's put the surface finish back on. Okay. Let's see. And there you go. So that's how you're going to put decals on. That's how you're going to do directional lighting. Any questions on this, folks? Very quiet this morning. Okay. So let's see, I've gone over colors, detail, background, and textures. So let's go back, and I want to go over exam stuff at this point. Anybody have any questions for the exam next week? Anything you guys want me to go over? Man, you guys need more coffee. Okay, then what I'm going to do is I am going to go do one of the homework problems that I assigned that was a former test. And let's see. Lesson 20. So let's download this U joint, and we'll go through the U joint. Okay, here is one of the first places that I saw people having trouble. When we get to the exam, a bunch of people had trouble because they couldn't explode the assembly I gave them. And what they were doing is they were creating a new assembly and they were bringing this in as a component, as a subassembly. Okay, do not do that. When we get to the exam, I want you to work right in the assembly file that I gave you. So the first thing we're going to do is we're going to arrange this thing into some nice orientation that we like. We're going to create a named view. So I'll go under View Orientation and call this My Explosion. And we'll do Insert, Exploded View. And now we just start pulling this stuff apart. So for step 1, I'm going to pull that out. When I've got it where I like it, I'm going to say Done. On the back, I'll pull this other yoke away. I'll say Done. I think this one's a little too far out, so I'm going to modify it. I'll bring that in a little bit. And I'll say Done.
You can take these caps, all of them all together out with one move.
Yes, certainly. Oh, what happened? Somehow I fell out of my exploded view.
You have to press Edit on the exploded view, right click and Edit feature. At the left. Yeah, right click there. One below. Edit feature, yeah.
Okay. And done. So I like that. Let's say I'm all messed up and I want to go back to my named exploded view. So I can go to the view orientations, go right back to my explosion. There we are. Okay, so we've got our explosion made. Now let's do our explode line sketch. So we'll insert, explode line sketch. And I would encourage you guys to always do these by hand. I'm going to go from the center of that. This is not the greatest example. In fact, I'm going to retire this one after this year. Because yes, I do want you to always avoid passing metal through metal. So if you need to, it might be helpful when you first get the exam question, take a section right through the part and take a look at which way you can move the components without passing through any solid metal. Always remember that when you start drawing, you're on the XY plane. So if you start getting lines going all crazy every which way off into space, that could be a very good reason why. Okay, remember, save often. You don't want to have any trauma or drama in the event of a crash, but they do happen. There's something about exams that tend to attract machine crashes. Okay, so I've got my explode line sketch. I can push this whole thing together without going metal through metal. I'm going to rebuild and save it. So if I want to, I can collapse it or re-explode it. Okay, that's all good. Now what we're going to do is make a drawing of this thing. Notice my hidden lines are turned on, folks. I think one of the graders might have been saying that you should have the hidden lines turned off on page 1. That is not correct. Okay, I do want to see the hidden lines. Okay, so I see a bunch of cylindrical faces. I see a bunch of round edges. So that immediately means that I've got to put in center lines and center marks. I'll choose those two edges, get a center line here. Okay, these center lines I'm drawing, they're too short, but that's okay. We can grab onto them and stretch them.
On this view, can you put a diagonal center line, meaning that it's symmetric on the diagonal?
A diagonal center line.
That goes through the where you put the grease in, that hole. From the top left towards the...
You could, but I just don't think it would be conventional. I know at least in the US that would cause a bunch of confusion. So I wouldn't personally go that way. Okay, so now I see my round edges. I'll put my center marks on those. One there, one there. That one didn't really matter. Save often, saving is good. Okay, so we got our center lines, center marks, hidden lines are turned on. I do need an isometric that matches. So insert, drawing view, and project it. I'm going to project this model up here. This does not have to be the same view size. I would encourage you guys to make it a little bit smaller. So instead of using the parent scale, we'll do custom and we'll go say quarter scale. And always make sure the hidden lines are turned off because you want it to look like a solid body just so the reader can visualize what you're talking about. Okay, I told you guys I want to see maximum length, width, and height all as reference. So those will be the first things we put on. We'll go overall length. Putting it in parentheses to make it reference. Good. And let's see. Okay. And I also told you guys that I wanted you to set the bearing cup depth at 0.126. Well, the top of the bearing cup in this thing is right at this line right here. And one of the biggest rules that I ding really, really, really hard for is dimensioning to a hidden line. We never, ever do that. So instead, what I would recommend is we'll get rid of this view. And let's put in a section view right down through the center of this thing so that I can see inside and put a live dimension for anything I need to position. I have vertical section chosen. That's good. I'll go right on the center of this hole. I'll come right over here. Always make sure your sections or any derived views start at AA. Okay, so that's good. And now we can set that press height that I wanted you guys to do. Go from here to here. And there are two ways you can do it. You could say 126, and you could go around to each one. That would be fine. Just like this. Otherwise, what you can do is just do it one time, and we can put on the suffix and say 4 places. So I'll come over to my dimension text, hit return, I'll go underneath, and I'll just say 4 places.
Would you need a center line for that sketch?
Yeah, you really do. That's a good call. Thank you.
I have a question.
Okay, Emmanuel, go for it.
So I put the dimension because you requested, but I think we don't really need it because it's between two parts and they are coincident.
Yeah, you actually do. And I've made this mistake. So there's an air gap right here and here.
Yes.
Okay. So if I press the bearing cup down too far, I could take up this space, and then the edge of the cup could slam into this side of the cross, and then it'll grind when I put the drive shaft in.
Yeah, right. But the cup is coincident with the notch where the ring goes.
Yes, it is, but there's nothing to stop it from continuing to slide downward.
Okay.
So if I put this in an arbor press and I press this bearing cup, I can just keep on going.
Yeah, but then it will not be true to the drawing.
Correct. But if I hand this to somebody that's never seen it before, how do they know what correct to the drawing means? Unless I put a dimension.
Okay, yeah.
Okay, so anything that I tell you guys to set, I expect to see a live dimension that's not reference. And of course, all the usual stuff. Make sure you fill out the title block completely. I don't want to see anything in this area. So as this part goes through its useful life, and I've got to put revisions in here, we never, ever, ever move the views. They always just stay in place. So we've got to have room to put that text in. That's why I harp about nothing under here.
We still can remove a view if we get all the dimensions elsewhere, right?
Before you release the part to production, yes.
Okay.
Once it's released to production, you would have to actually do an engineering change just to get rid of the view.
Okay.
If there's any difference in appearance, in my experience, the manufacturing guys will go crazy. So you just don't change anything. And if you do change it, you got to get buy-in from everybody in production. All right, so sheet 2. We'll put in our exploded view. So insert drawing view and model. We'll choose the U-joint, show an exploded state. We'll choose my explosion. There we go. So now my exploded view is on there nicely. While we're here, we may as well put our bill of material balloons on. Now, some of you guys are having video card issues where your arrows are pointing off into space. Don't worry about that on the exam. That's something I've seen. I know it exists, and I'm certainly not going to ding you for Dell's bad design choices in video cards. Okay, so there's all of my balloons in place. We're going to add another sheet now.
Is the cross balloon?
Yep, good call. -5 for me. Okay, now we're done. So we'll insert another sheet, insert sheet. So we're going to choose B size sheet 2 format. We'll say OK. And I'll go back to sheet 2. Let's get our bill of material. We'll do insert, tables, and bill of materials. We'll click on the view so that we can get some data for our bill of materials. Okay, I've seen a couple problems in the homework where people didn't have the class BOM template. They were wondering why things look different. Okay, make sure it says MEE 120 BOM template right here. If it does not, hit the little blue star and surf over to your templates folder. This is where the BOM template should be. And also make sure you've got top level only. Once you've got all of that, say OK. Here's your bill of materials, and just drop it right on sheet 3. And then we'll go in, we'll clean up our title block. So today is 11/10. Where did this year go? Let's see. So our scale, I saw a bunch of people having problems with understanding what the scale meant. Okay, so we're going to choose our orthographic views. These are the ones with the hidden lines. And we got use sheet scale, and it's 1:2. Okay, so with this scale down here, what this means when it says 2:1, that means that the stuff that's displayed in the paper is twice the size of what the part actually is. Because these U-joints are relatively large, and we've got 1:2 scale, that means that the paper is going to be half the scale of the actual part. So if I measure this, if I've got one of these on the table, it'll be 8¼ inches long. But if I were to take a ruler and measure my blueprint, this would be 4 1/8 representation. So we'll fix the scale. And mine always acts out. Okay, remember that the part number, the revision, and the drawing title, these are all coming from the assembly attributes. So if you needed to change any of this stuff for whatever reason, go back into the assembly, change the attributes there. So this scale, this one is 1 to 2 also. 1 to 2 or half scale. It's 3-page drawing, so it's 2 of 3. There are no graphics on the BOM page, so I always just put NA, not applicable. And it will be sheet 3 of 3. Okay, and that's all I wanted for the assembly drawing. Okay, next I asked you guys to do the yoke. So let me save this. And I'll go right over to sheet 1. And let's open the yoke. All right, so we'll make a drawing of this thing. How are we doing for time? If any of you guys need to take off before I'm done, feel free. I don't want to make you late for another class. All right, so we'll get rid of this. The scale is just too large on this thing, so let's make it a little bit smaller. I'll do a custom scale. Let's do half scale. Okay, if you just do this, guys, I'm going to have a nutty over this. Okay, all the edges must line up and everything must move together. Yes, it moves together, but this absolutely does not make sense. Okay, there's no way I can project this edge in the glass box and see this edge down here. Likewise, I can't project this edge and see it in the glass box up there. So that is really important. In fact, I'm just going to get rid of this. Let me get rid of this. And let's reproject these views. So insert drawing view and project it. Turn off our hidden lines. We'll tuck our isometric right up there. Okay. So I can immediately see a problem. I've got a bunch of internal stuff and I have no way to see inside there. So that's immediately screaming out to me that I'm going to need some kind of section view to see inside and get that little internal groove. But first, let's start off with the most basic dimensions. So we always want to tell the machinist how big a block of metal they're going to need to make this part. So we're going to do the overall dimensions first. We'll grab our smart dimension, maximum height, do maximum width, and depth. Okay, we'll do our center lines. And let's put in our section view so we can actually see inside of those snap rings. So insert, drawing view, and section. Always make sure we start at AA. Okay, so let's get some of our major dimensions taken out. So the height of the shaft, 2 inches. And then I am not going to put a dimension here because that would be double dimensioning. With the shaft diameter. And I'm going to try to avoid crossing as many lines as possible. Sometimes it's unavoidable, but try to keep everything clean and easy to understand. In fact, that makes this kind of a bad choice. Let's put that over here. Okay. So we're going to assume the part is symmetric. I'll grab that center line and drag it up. Again, save often. So now let's do this cutout region. Again, whenever possible, go to edges that you can touch. Okay, so now we have the centering of this cutout and we have the height of the cutout. Okay, we're looking good. So I've got the shaft feature located and defined. I've got this upper blocky section done. I've got the cutout done. I've got this rounded over section done. I'm looking pretty good. We can do the hole right here. So then the biggest thing I need over here is the dimensioning for my snap ring grooves.
Did you have the overall dimension of that, the width of that part?
Yes, that's what I started with. So I've got 5 as my height,
Gotcha.
3 1/4, and that one.
I had a quick question before I head out.
Yeah, Sam, go for it.
It's not on this part, it's on the cross.
Okay.
On those little cylindrical like bosses,
Right.
the 4 of them. You mentioned in mine that they, like, I didn't say that they were centered on the face. I was just wondering how you would do that.
Okay. So if we do something like this, so if we put the center line right through everything, that's going to say that this boss is aligned with this boss. And then you could come up here. Okay, so this would establish the centering of the boss. And these center lines would say they're all in line with each other.
All right, thanks.
Okay, so we're just about out of time. But the thing I wanted to see on this problem, I was driving it, wanting you guys to locate this hole. And since you can't just position it on an angled face, you got to be looking directly perpendicular at a face. That drives you to an auxiliary view. So insert drawing view, and we'll do auxiliary. We'll choose the edge we want to project off of. A. And then always lift the arrow off like this. Because the width of this auxiliary view should be the width of the view that I'm looking at, and the arrow points in the direction my eye is looking. Rebuild it, save it. And now I can position that hole properly.
Can you avoid this dimension, the half-inch, if you put a symmetrical, because it's in the center? If you put a symmetrical line, not diagonal.
Yeah, you probably could. So let's see if we do something like this.
Yeah, this is what I did.
Yeah, I could certainly buy that. That's reasonable, especially if we're saying up here that we're going to come a ½ inch off this face. We're going to put our boss, and then this is running right through the centers of the bosses. Yeah, okay. And let's see. So I got a little bit off track. I should have started with maximum length, width, and height. So I've got width. Let's do thickness. And we'll do height. So 0.75. If I really want to be explicit, I could say 4 places. Remember, always in all caps. I need the height of the boss. I need my whole call out. So we'll do insert, we'll go down to annotations and whole call out. And let's see. And one of the last things I'm going to need is always make sure you've got a material note, because we need to know what to make this out of. Since you guys haven't had materials, I'm going to be sure to assign materials to all of the models. So if I open the cross, this is AISI 1015 steel. We're going to put that in with a note. And now we just need to do a little rearranging because I'm under the revision block. There. And let's see, did I miss anything?
You have a double one on the half-inch. It's on the auxiliary and on the top view as well, right?
Yeah. You probably could get rid of one, okay, because it's going through the center line of the part. You know, otherwise, if it was not, I would say yes, you had to have them both. But yes, always avoid double dimensioning. That's one of the big no-nos.
Because this piece it has so many symmetries, I end up putting only 4 plus 1 the whole 5 dimensions altogether.
Yeah. Yeah, you could. I mean, in something like that, I would just want to see some kind of a modifier like the 4 places, just to say explicitly that yes, they are all the same. And if you do that, okay, sure.
Yeah, I did. Let's see what the grader will say.
Yeah, the grader's a real jerk on this one. Okay, and unless I've missed anything, this is what I would be looking for.
I had a question about the Stirling engine.
Okay.
Did you ever get around to making the video of like taking yours apart and like putting it back together?
Oh, shoot, I still owe you that, don't I?
Yeah.
I did not. Okay. And I've got it sitting here right next to me. So if I don't have that posted by the end of the day, ping me and just annoy the heck out of me, and I will get that today.
Okay, thank you so much. I really appreciate it.
I owe that to you guys, so I will do that. Thank you for the reminder.
Yeah, of course.
Okay, so that's what I was looking for, and that was a full exam in a past year. Okay, guys?
So there's no homework this week, correct?
Nope. Nope, just get ready for the test.
Okay, cool.
I can give you some if you want.
No.
Oh, come on,
No.
Emmanuel.
I want to work on my Sterling project. That's like a million times homework.
Well, yeah.
I'm in this position that now I'm bored. I need more challenging stuff that looks so easy.
Well, we're going to do free forms after the exam, and I'm going to have you guys chop up a Spitfire wing from World War II and do ribs for a Spitfire wing. We're going to talk about we're going to talk about filing components down from the assembly level into component files, which is really convenient when you've got difficult stuff like an elliptical Spitfire wing. If I had to do a tapered and twisted wing layout for that shape, oh, that'd be awful. But if you do it at the assembly level, it's quite easy. So you'll get more fun stuff, Emmanuel.
Okay.
All right, guys, let's wrap it up for here. And as you prep for the test, if you have any questions, just drop me an email. And if we need to, we can Zoom. Okay?
Thank you.
Thanks, folks. Take care.
We don't have class tomorrow, correct?
Correct. Veterans
Okay.
Day.
All right. Happy Veterans Day. Have a nice week.
You too. Bye-bye.
Bye-bye.